Hello guys, we are going to show you the Riemann sums. Let's take a look. So today's Riemann sum, we're going to have f of x is equal to x squared plus 4, and we are going to go from 0 to 2. And we have 4 triangles. So the first thing we're going to do is find the delta x. This is found with the formula b minus a divided by n. So it's going to look like this. And when you simplify it, it's going to leave us with 1/2. That means that we are going to have 4 triangles with this measurement between 0 and 2. So let's write them. 0, 0.5, 1, 1.5, and 2. Right now we are going to use the right hand approach. So we are going to take these 4 numbers in the area. Now let's take a look at the table of values. Since we're going from 0 to 2, we are going to start at minus 1, 0, 1, 2, and 3 to give us some space. So the graph is going to look like this. Now we're going to graph from 0 to 2, but we are going to use these numbers over here because it's the right hand approach, and we are going to graph 4 triangles. So we're going to go from 2 to 0.5 until we stop until the next number. Now we have here something that's called an overestimation. Now we're going to find the area. To find the area, we're going to leave the delta x outside, and we're going to plug these numbers into this equation. So we're going to have 0.5 squared plus 4 plus 1 squared plus 4 plus 1.5 squared plus 4 plus 2 squared plus 4. When you plug this into a calculator, it's going to give us 23.5, and then we are going to multiply it by the delta x, and it's going to leave us this. But remember, this is area, so it's going to be units squared. Thank you.
Hi, my name is Gerardo, and today we're gonna be finding the area with calculus. First of all, we're gonna be integrating this problem, which is gonna be x to the third power over 3 plus 4x. Now we're gonna be finding the area between A and B. So in this case it's 0 and 2. So we're gonna be putting this sign from 0 to 2. Now we're gonna be plugging, first of all, the biggest number. In this case is the 2. And in this case, we're gonna be plugging the lower number, which is in this case is 0. So now that we are gonna be collecting the the values of this part of the problem, which is in this case 10.6. So 10.6 minus 0 gives you 10.6 unit square area. With this problem, we can learn that with Riemann sums, we're getting an approximation, an overestimation. This gives you a bigger answer, a bigger value than the exact number that we get by using calculus.
Hi everyone, I am Arturo, and today I will be explaining Riemann sums with a left-hand approach. So to start off, we have the equation, which is going to be 2x squared minus 3x and we're going to have to work with 0 to 4 using only 4 rectangles and the left-hand approach, as I just mentioned. So to start off, we're going to have to come up with the delta x. Well, not come up, but find it, which is the formula for it is b minus a divided by n. The b is our second number, so it's going to be 4 minus a is going to be our first number, so 0 divided by n, which is going to be the number of rectangles, which is 4. So our dx will be 1. Now, this delta x, what it's telling us is going to be the difference between each number from 0 to 4. So our numbers are going to be 0, 1, 2, 3, and 4. But since we're doing left-hand approach, we're only going to be using these 4 numbers, our first 4 numbers, excluding the 4. So now the formula that we're going to use is going to be the delta x. We're going to leave it outside, and now we're going to be open the big brackets. Now it's going to be the function of 0, which is our first number, plus function of 1, plus function of 2, plus function of 3, and then ending on 3 since we're not using the 4. So now let's plug in the values. Delta x is 1, and now the function of 0, we're going to plug in 0 in this equation. So let's open the big parenthesis. 2 times 0 squared minus 3 times 0, close the parentheses, plus 1, which is the dx, times 10, which is going to be our final answer. So our final answer is 10 units squared.
So we are going to find the area of this function using calculus. So the first step we're going to do is integrate the function. That's going to leave us with this over here. And remember, we're using these boundaries, so it's going to look like this. Now we're going to plug this value on both x's minus this value on both x's. So after plugging this into a calculator, the area is going to give us 18.67. Now, if you see here, this is the exact answer. When we used Riemann sums, the answer we had was 10. In this problem, we have the actual answer. So remember, this is an underestimation. That's why it's not so accurate.